Good afternoon, everyone. Bradley Simmons, and today we'll be going over exploring engineering and management from Module 4. This presentation explores key texts that have shaped the fields of engineering and management, providing insights into the historical development and contemporary relevance. The engineer in history, John Ray and Rudy Bolte. The book explores the social backgrounds and training of engineers throughout history, from skilled artisans in antiquity to the emergence of formal engineering education in the modern era. Employer relationships it examines the revolving relationship between the engineers and employers, including the rise of professional organizations and the development of engineering codes of ethics. The book highlights the contributions of notable engineers such as James Watts, George Stephenson, and John Smeaton, which inventions and innovations transform society. The principles of scientific management. Efficiency and productivity. Taylor's work revolutionized management by emphasizing scientific methods to improve efficiency and productivity. He introduced time and motion studies. His key principles involved the importance of scientific work methods, worker selection and training, and the separation of planning from execution, laying the foundation for modern management principles or practices. The movement envisioned a society where technological experts would manage resources and production based on a scientific understanding of the energy and resource consumption. Techromatz applied thermodynamic principles to the social phenomena, arguing that society should be organized based on energy flow and resource ability rather than economic factors. Techromatic ideas remain relevant in today's world as we gamble with issues of resource scarcity, environmental sustainability, and the impact of technology on society.
I would like to start off with a brief introduction of the Cold War, which was from 1945 to 1991. This time, the U.S. does not demobilize after World War II, which they have done in the past wars. This starts a competition between Russia and the U.S. in arms race. The support for military tech increases for spending and leads to a nuclear weapons arms race, including space. There are proxy wars that start across the globe in areas like Korea, Vietnam, and Afghanistan. And after the smoke clears and everything is done, the U.S. emerges as the only superpower at the end of the Cold War in the early 90s. The next slide is the military and engineering in the United States, which is considered 4 periods. First at West Point's education in engineering was drawn from French techniques of engineering. We then move on to the Civil War with Eli Whitney and increasing his industrial techniques of trying to create modular weapons. It's not a success, but going in the right direction. Then we move on to the Army Corps of Engineers with the introduction to the steamboat engine, helped expand to the West. Then into World War I, we see the development of tanks and aircraft, and then it increases up into World War II with also the introduction of radar and commuting systems, and then moves into the Manhattan Project towards the end of the war, which sees the first detonations of nuclear weapons on Japan and the only ever used. Our next slide is engineers in the Cold War. Almost 50% of engineers are being used for weapon development and Cold War projects such as ArcNet, Start the Internet, SAGE, Star Wars, and the space race. These projects were a success and also failures, but all information gathered from these expanded to other projects that will for success down the line. This also includes the start of a military industrial university complex, which puts schools in situations to develop weapons for the military that is separate than the teachings of the school. And the last slide of engineering in the Cold War wasn't worth it. We did see industrial growth. Focus on military spending could have been used elsewhere, such as education, health, or development of our own cities. We did see a rise in new technologies such as aircraft travel, but we started to see a lot of protests for conflicts outside the US. And even with the end of the Cold War, it feels like we have unfinished business in our current climate, and only time will tell how it will end.
Hello, my name is Heather Lee Morton, and I am in Group 4D for Class 318 History of Engineering. To start off with, I'd like to talk about the history of computers. Some early history of computing is traced back to Charles Babbage on his creation of the difference engine in 1820. This was an automatic mechanical calculator that would compute polynomial functions. Ada Lovelace, who was a mathematician, was also instrumental to the creation of this device, since she figured out how to make computations for it. Now going 120 years in the future to the early 1940s, the word computer was used to refer to people who would calculate math equations for industries like the military and calculating things like ballistic tables for missile range accuracy. Then, in 1945, there was the creation of the Electronic Numerical Integer and Compiler, the ENIAC. This was designed by the University of Pennsylvania with a collaboration by the Aberdeen Proving Ground, an Army-based company from Maryland. This machine did the work of calculating ballistic tables in a matter of seconds. After these inventions comes a huge step in computers, which is the invention of the compiler by Grace Hopper. Instructions would be entered into a machine, and a compiler's job would be to convert the instructions into binary code. Grace went on to create the first programming language called COBOL. Moving on to algorithms, there are certain characteristics of most algorithms. They are mostly developed by private companies that create them for commercial purposes and for profit. They also highly emphasize the need for direct efficiency in computing the ingoing information. This has been a major point of contention in society because this desire for perfect efficiency can cultivate results that can be discriminatory and biased. Like, for example, there can be some biasm for social services qualification. This has included an accurate process for using algorithms to calculate child abuse risk score, without monitoring if all the information is accurate or fully added to the system. Search engines. The major role of this modern technology is to make a profit off of people. The qualms of this is that search engines present information to people off of what they want to see rather than what they should see. A person who has done extensive research on search engines and their biases is Safiya Noble. Her research on search engines points out how these tools have caused racist results in African American women, as well as egregious sexual objectification. It used to be that even typing the word black into a search engine would return racist results, like why are black people evil? She advocated for fixing of these search engines as they pose a major threat to equality in society. Another problem is how this data collected on people has been sold to spy agencies that track people's internet searches and data. Like said in this week's lecture, there's a major difference between the efficacy of an algorithm to make profit and the efficacy of an algorithm to protect society and human decency.